What's up, compressed air friends? So, with the heat upon us and refrigerated dryer season now in full swing, I thought I would show you guys a couple of real quick things on these little Beko dryers. We have a million of these out in the service, and the call I frequently get from both technicians and customers on these is, my display is dead. And before you go chasing through your wiring diagram trying to figure out why that display is dead, take these 4 screws off the top here and remove this top piece and just reach right here and reset your high head pressure button there. All right, now we're back. So it turns out you got to wait a little bit, let the pressure come down before it'll actually reset. But so now with that high head pressure switch reset, our controller will come to life, and the dryer will attempt to restart. I'm not going to let it do that because I know what's wrong with it, and I don't want things to happen. But one of the things to look for on these Bekos like this is, if we come around to the side, right down there, we have a liquid line solenoid. That solenoid has to open to allow refrigerant to flow to the evaporator and thus cool things down. If that solenoid valve does not open, you will quickly build up high head pressure and you will trip this switch right here. Same thing happens if, for example, our evaporator coil is our condenser coil is dirty, something like that. So it's just a standard high pressure fault. But if that little solenoid right there does not open, you will quickly get a high pressure fault. So let me stop for a minute, and I'll get set up with a quick and easy test you can do on that coil to find out if it's working. You don't need a voltmeter. You don't even need to know where it is on the wiring diagram. So give me a second to get set up for that, and I'll show you guys the quick and dirty way to test this thing. All right, friends. So as you can see, I have disconnected the coil from this solenoid valve, and I now have a screwdriver right through the middle here. So what's going to happen is, when I turn this machine on, it's going to energize this coil, and my screwdriver is going to go, and it's going to stick to one side due to the magnetic field. That's going to tell us that this coil is being energized. So, dryer's on. I don't know if you can hear that thing buzzing a little bit, but yeah, there's a good magnetic field there. So, go ahead and shut this back off, and now we're back to nice and loosey-goosey. So what this test has confirmed for me is that there is voltage getting to this coil, and that this coil is indeed inducing a magnetic field onto that stem, as it should, which will then retract that plunger and allow refrigerant to flow. So that has tested perfectly well and good. So we're going to put him back on. Now, just so you guys know, if you do find that this coil has gone bad, and they do go bad, I found this a few times, what you have right up here is you have the exact same solenoid valve with the exact same coil. That is for the energy saving system on this dryer. And so if you are in a pinch, you can actually remove this coil, put it down there on the liquid line solenoid valve, and just leave this on, either plug the old bad one in, or just leave this plug hanging. It doesn't matter. And then you go into the controller, and you're going to set ESS to no. And what that will do is that will eliminate the need for this solenoid valve, and your dryer now becomes a standard non-cycling dryer. You may need to adjust this a little bit, you may not, whatever, but your dryer basically becomes a non-cycling dryer at that point, and it'll run and it'll keep your customer running long enough so that you can get, if it was me, I would order 2 new solenoids, put them on, and then if so desired, you can turn your ESS back on. But moving on here, so what's actually wrong with this dryer today is a lot of times what I'm finding is I will find that high head pressure switch tripped, and then when you open the cabinet, you actually find the fan motor overload tripped. And these fan motors are a little bit strange. And then if you look at the wiring diagram here, you can see there's QV1, that's our fan motor overload. And then there's our KV1, that would be our starter right there. And that goes down and powers up our fan. Well, down here in the fan, we also have these 2 little T-leads right here. And so what this is this cooling fan's actually double protected. So we have our overload relay, which protects it from overcurrent, but then we have the T-leads that come up from the fan itself. Those actually protect it from the fan getting too hot. So it's kind of double protected. So what'll happen is your main motor overload here will trip, but because this is not tied into the control circuit for this, your starter will remain pulled in, but there is no voltage coming through here to the fan. The voltage stops right here when this trips. So you'll have voltage to here, this trips, you now lose your 480 going down to that fan, even though this contactor will remain pulled in. Now, the T-leads, on the other hand, if we flip to the control side of this wiring diagram, and we look at this line right here, this is our control line. Let me get this, there we go. This is our control line for the cooling fan. So we've got our 230 here. It's going to come down through our fan switch, and then it's going to hit our junction blocks over here. And then right here, this MV1, that's showing us the T-leads on that fan. Then it comes down to the coil for KV1. So if the fan thoroughly trips, the starter disengages. If the fan trips on overload, the overload relay trips, but the starter will remain engaged. All right, so don't let that fool you. So what we've got going on here is we actually have a cooling fan motor that appears to be shorted to ground. I'm going to verify that with the Megger here in just a moment, but I'm 99% certain that's what's going on. So as soon as the dryer starts up and it goes to call for the cooling fan, the starter pulls in, the cooling fan trips the overload relay, but the starter remains pulled in because this is not tied to the control circuit for this. And if you're not really paying attention, you'll look in here and they'll go, well, my fan relay's pulled, or yeah, my fan relay's pulled in, but nothing's going on here. Well, that's why. So I've actually seen this a few times already this summer, where we have a bad cooling fan, but because the control circuit is not well understood, we end up with a misdiagnosis of either we've got a bad controller, which the only way to get this is to buy that, and that's an expensive combination, or any other number of things that we see on these. Real quick, just to show you guys. So this is the power that feeds our I/O module, which in turn feeds our display through this ribbon cable. And so you got X1 and X2 there, hot and neutral. You can see it shows a jumper between X1.3 and 1.4. Back to our jumper conversation. That is right here. And if you remove that jumper and replace it with a switch, that is our remote on off. as noted here in the wiring diagram. Then it comes through the high pressure switch, that guy right there. So if that high pressure switch trips, it actually kills power to the entire I/O module, which also kills power to this display. And that is why it can be a bit misleading when you're trying to diagnose these dryers if you don't know that that high pressure switch actually kills power to this whole circuit. All you know is, I got a dead display and I got to start troubleshooting that. Well, in this case, like I said today, and I've seen this a few other times, our dead display here is actually due to a bad fan motor. So how crazy is that? So I'm going to disconnect this fan and do a test on it and just see it, you know, verify, yeah, is it shorted to ground? And what I'll do then is I'll leave that fan unhooked. I will put my trusty Milwaukee fan right in front of the condenser here, and I will run this thing for a little bit with my fan blowing on it and make sure we don't have any other issues. And as long as it passes that test, then we know, hey, we just need a new fan motor. So let me get set up for this test and we will do that, and I'll show you guys how that looks. So I'll be back in just a moment. All right, friends, this is going to be a little bit of a back and forth show here, but so you can see I've got, obviously my power's off to my dryer. I've got my fan motor disconnected, my meter set up for insulation test, 500 volts. I've got my negative side just clipped to the DIN rail here for a ground, and I've got my positive side hooked to this wire here, and we are going to test, and it passes. And we're going to go to another leg, and you always want to make sure that your other two legs are not touching anything else. I know that black wire looks like it's laying up against the blue there, but it's not. That's just an angle thing. So on the blue wire now, we'll hit test, and that passes. And then we'll grab this black wire. I think it's pretty safe to assume that this black wire is going to pass. The other two legs did. Yes. Okay, so the fan motor passes the Megger test. So what we're going to do now, we're going to set this bad boy to ohms, and we're just going to leave that red wire clipped right, or that red lead clipped right on there. Put this black wire on, and that is extremely high for a motor, for reading motor windings. Okay, now we'll go to the other one, and we get an even more outrageous number. And then if we read back between these two, we end up with a low but still outrageous number. So kind of a general rule of thumb with any kind of three-phase motor like this, the actual ohm readings really are not all that important. I mean, in this case, that's actually extremely stupid high. But what you're really looking for is you're looking to have the same ohm reading no matter which two leads you're clipped onto. And so this right here tells me this fan motor is internally shot. Windings are not wide open, but they may as well be. So even though so what the Megger test tells us is if the fan is shorted to ground or not, and it's not shorted to ground, but we are seeing a high resistance, and the fact that the resistance reading changes, you know, between each winding tested, those inconsistent numbers pretty much tell us all we need to know about this fan motor. So nothing left to do now, but I'm going to tuck these wires into the cabinet here. I'm going to put my trusty Milwaukee fan right here in front of this condenser and run this dog and make sure we don't have any other issues. And then I can let my customer know that, hey, Mr. Customer, you need a new cooling fan. So that's what I'm going to do. If anything interesting pops up along that way, I'll be sure to let you guys know. Otherwise, I'm going to say this thing's goose is cooked. And yeah, once I see this thing run for a little bit with my fan in front of it, I'm going to go the hell home. So that's what I got. See ya. Well, there you have it, compressed air friends. We got a 37-degree chiller temp. Cooling fan is unplugged and capped off. And got my little Milwaukee in front of the condenser. And this guy's happy. So, we'll get a cooling fan ordered for this guy. And, you know, one of the reasons why I highly recommend that when you suspect a cooling fan is no good, so just go ahead, disconnect it, and stick your own little fan in front of it. It doesn't have to be a super cool Milwaukee one like mine, even though it is super cool. But I mean, a little box fan from Walmart does just fine as well. But I highly recommend that you do that, because if there's any other issues lurking in this dryer, with this fan sitting in front of the condenser here and test running this thing, you're going to find it. And then instead of going to your customer and saying, okay, Mr. or Mrs. Customer, you need a new cooling fan, and they say, okay, you come out, you put a new cooling fan in, and oh man, lo and behold, we have a high pressure switch tripping out too early, or maybe the fan switch itself is wonky. I mean, any number of the other little things that can go wrong in a dryer like this. When you take the failed part out of the equation, put a temporary solution in and run it, you're going to catch any of those other little gremlins that pop up. And then instead of having to say, oh, well, we just put this new cooling fan, but now you got to put more money into this dryer because we found X. You can come back in one trip and go, okay, we found the cooling fan was bad. We ran with the auxiliary fan. When we test ran that, we found problem X as well. And you catch it all on the next trip, and you look like the hero. So, and that's what we want, right? So, yeah, I'm going to say this guy is he's fine. 37 degrees. Everything looks real good to me. I'm not seeing anything that gives me any kind of concern or anything. So we're going to write this up for a straight up cooling fan, and that's going to be that. So there you have it, friends. See ya.